Yeah, I know. I'm using the AI voice generator again. So what? I thinks it does a perfect job. It's all about the content of the argument, not about who's saying it, right? Anyway, in this video, I'm going to explain and show in great detail what exactly happens in an elastic collision. I'm also going to explain why there is no such thing as free momentum, as draft science claims there is in a typical elastic collision. Since I've been doing the classical collision with 1:3 mass ratio marbles once again, I'm going to use this example for my explanation. To explain this as clearly as possible, I'm going to use a simulation where we can see the collision happening step by step, and where we can see how momentum is transferred from the 1 mass into the 3 mass. To make this as clear as possible, the balls are extremely elastic in the simulation. In this way, you can clearly see the compression and decompression of the balls. In reality, you can't see the compression and decompression of the balls, and of course, it all happens in a very short period of time. All right, so here are 5 important steps that happen during the process of a collision. Step 1. The initial condition before collision. The 1 mass is moving towards the 3 mass with a certain velocity. The 3 mass is stationary. The atoms in the 1 mass are vibrating in the direction of motion. The atoms in the 3 mass are stationary but can move when a force is applied. Now, of course, every single atom in the 3 mass are not literally stationary. They are moving and vibrating, but the marble as a whole doesn't move. The vibrating atoms do not cause to move the entire marble in a direction with a certain velocity. The velocity for the marble as a whole is 0. At this point, all the system's momentum is in the 1 mass. Step 2. First contact, compression begins. The 1 mass touches the surface of the 3 mass, and the outermost atoms of both objects begin to interact via electromagnetic forces. The repulsion between electron clouds in the materials prevent the objects from passing through each other. The 1 mass pushes on the atoms of the 3 mass, thereby compressing the contact area slightly. At this moment, the atoms of the 1 mass are slowing down as they exert force on the atoms of the 3 mass. And so now the 3 mass start accelerating. At this point, momentum begins transferring to the 3 mass. Step 3. Ongoing compression. The 3 mass is still accelerating more to the right, gaining momentum. The 1 mass is still slowing down, losing momentum. Both masses are moving. The repelling force increases as the materials compress more. Step 4. Maximum compression, full momentum transfer. The 1 mass continues pushing into the 3 mass, compressing it like a spring until it reaches its maximum compression. The 3 mass has now fully absorbed all the momentum of the 1 mass. The 1 mass momentarily comes to a full stop because all of its momentum is now inside the compressed atomic structure of the 3 mass. The contact area is maximally compressed, and the atoms in the 3 mass are now pushing back due to their electromagnetic repulsion. They basically act like microscopic springs. At this moment, the 1 mass has 0 momentum since it comes to a full stop. The 3 mass has all the initial momentum. At this single instant, at the point of maximum compression, they're not pushing against each other anymore. Now, before I continue with step 5, you should know that draft science also doesn't even agree with this. Conventional science says first the 1 mass has to transfer all of its momentum to the 3 mass, but draft science says, nope, the 1 mass does not transfer all its momentum. Rather, it keeps some momentum for itself. It doesn't go down all the way to 0. But obviously, at the point of maximum compression, the 1 mass comes to a full stop, which means it's stationary, it doesn't move, therefore it has no motion, therefore it has no momentum. But draft science says, well, yes, there is still motion, of course. All the atoms inside the marble are moving, so there still is momentum inside the marble. But again, yes, even though the atoms inside the marbles are moving, they do not cause the marble as a whole to move in a certain direction. The marble as a whole remains stationary. And that's the point of momentum. We look at objects or system as a whole. Everything that happens inside the objects or systems are internal forms of motion, and they do not cause the objects or systems to move in a certain direction. Now let's follow draft science's logic for a moment. Even though the 1 mass is stationary, its momentum is not 0, because all the atoms inside the marble are moving, and so they all have momentum. So this means the total momentum of the stationary 1 mass is not 0, but 2, for example. Let's go through the entire collision process once again, but with respect to draft science's logic. Before collision, the one mass is moving at 10 meters per second, and the three mass is stationary, so 0 meters per second. But even though the three mass is stationary, it still has momentum because all the atoms inside it are moving. So its momentum is not 0, but let's say 2 or maybe even 3, because a 3 mass is bigger than a 1 mass. And so a 3 mass contains a lot more moving atoms. So more momentum. Now, if a stationary mass already has momentum, then if that mass starts moving in a direction, its momentum will increase. So basically, we have stationary momentum plus moving momentum, and that equals total momentum. Okay, so the one mass is moving at 10 meters per second, so its total momentum is its stationary momentum, which is 2, for example, plus its moving momentum, which is 10. So its total momentum is actually 12. This means that the total momentum of the system is 12 plus 3 equals 15. Well, at least it has to be more than 10. So now draft science predicts after collision, both masses should reflect with a quarter of the initial velocity. But what is the initial velocity? Is it 10 meters per second? Because that's only 10 momentum. But that's only the velocity of the marble as a whole moving. What about all the atoms inside the marbles moving? That's extra momentum that has to be accounted for. As you can see, if we apply draft science's logic, it's pretty vague and unclear what the initial total momentum is, and it's difficult to predict what will happen to the momenta during and after collision. If a stationary mass already contains momentum, why does draft science never mention this in all the other elastic collision videos? All right, so let's finally get back to Step 5, expansion or decompression. The three mass pushes back. The compressed atoms of the three mass now rebound due to elastic forces, thereby pushing back on the atoms of the one mass. So the force direction reverses. The compressed material starts to expand like a spring. The heavier three mass doesn't stop. Instead, it continues moving forward. But some of the momentum is now redistributed. Because the three mass is 3 times heavier, it does not need to slow down much to push the one mass back. The repelling force from the three mass sends the one mass backward with some of the redistributed momentum. Okay, those were the 5 steps. So now I'm going to explain why there is no such thing as free momentum, so this might be the most interesting part. In order to understand this perfectly, I will show you how momentum is being transferred, step by step, 1 unit of momentum per 1 unit of momentum. So over here we see the one mass moving towards the three mass at 10 meters per second, so its momentum is 10. The three mass is stationary, so its momentum is 0. At the moment of first contact, the one mass starts to push into the three mass. At this point, 1 unit of momentum is transferred to the three mass. So the one mass now has 9 momentum, and the three mass has 1 momentum. This means that the one mass has slowed down to 9 meters per second, and the three mass has speeded up to 0.33 meters per second. Right now, the first mass has transferred another unit of momentum, and the third mass has gained another unit of momentum. This process continues until the one mass has lost all of its momentum, and the three mass has absorbed all of the initial momentum. At the point where the one mass has transferred all of its momentum to the three mass, the maximum compression has been reached. The one mass has come to a full stop. Right after this moment, the one mass will bounce back in the opposite direction. This is the crucial moment to understand why there is no free momentum. So at this point, the three mass has absorbed all the momentum of the one mass, and it has reached a velocity of 3.33 meters per second. So let this be clear. At this point, the three mass has 10 momentum, and it is moving at 3.33 meters per second to the right. Right now, what will happen is, the three mass will now redistribute the 10 momentum. It will redistribute the 10 momentum by giving back 5 momentum to the one mass and by keeping 5 momentum for itself. This means that the three mass will gain 5 momentum and the one mass will gain 5 momentum. It's that simple. In short, the first mass gives all of its 10 momentum to the third mass at the point of maximum compression. Then, during the decompression phase, the 3 mass gives back 5 momentum to the 1 mass and keeps 5 momentum for itself. So the initial 10 momentum is simply being redistributed between the 1 mass and the 3 mass. No extra free momentum was created whatsoever. The 10 units of momentum got redistributed, that's all. The reason why it looks like free momentum is because the initial momentum is 10, because the initial velocity of the 1 mass is 10 meters per second. Then, after collision, the 3 mass continues with 1/2 of the initial velocity, which means its momentum is 15. But 15 is more than 10, so we have free momentum. But no, at the moment of maximum compression, the 3 mass has a velocity of 3.33 meters per second, so its momentum is 10. Then it gives back 5 momentum to the 1 mass and keeps 5 momentum for itself. This 5 momentum is being added to the 10 momentum that the 3 mass already absorbed during maximum compression phase. But if we don't do that, then the numbers remain perfectly symmetrical. 10 momentum goes in and is absorbed by the 3 mass, and after collision, the 3 mass gives 5 back to the 1 mass and keeps 5 for itself. And there you go, no extra free momentum.
As always, this video was an absolute waste of time and energy, especially when it is the intention to make a fucking counterargument for draft shit science. The difference between vector and scalar, momentum, and kinetic fucking energy will forever remain impossible to explain to Gary Science. Why the hell am I yelling like this? It's pretty fun to use the AI voice generators. Thanks for watching! God damn it!